It's not a good thing. So let's go ahead and try to get the most out of this class. Let's see where. Are there any questions about subroutines? You know, all the concepts that we talked about last week. I have the recorder up and running again, so what I talk about today, you know, will be recorded. There will be some repetitions of what we talked about last week. So, you know, even though we could not do any recording last week, I think today we can kind of make it up because there will be some repetitions. All the stuff that we learned from last week are still applicable this week. We're just adding on top of what we have learned, you know, so far. So I think that's not a bad thing, even though we lost, 1 week's worth of recording, just by recording what we can do today, I think we can still make it up. Where we are at right now is subroutine control flow is all done already. That's just how to remember where you're supposed to go back to at the end of a subroutine. We are now in local variables and parameters. And particularly, we are done with local variables. So before we go forward to talk about parameters, let's just do one more example using local variables. And this time we can use a recursive example to calculate factorial. I think last time we talked about factorial, how factorial can be written in a recursive way by saying, let me just remind you guys what we talked about last week. So essentially, we can say 5 factorial is 5 times 4 factorial. Okay, and then we can rewrite 4 factorial as 4 times 3 factorial, and so on. Now this has to stop at some point because otherwise the whole thing does not stop. So the way you stop it is you say dot dot dot. When we get to 0 factorial, by definition it is 1. That's how we stop it. Okay. Are there any questions about the recursive definition of factorial? No questions? Now we also talked about how recursion is useful. For instance, when you want to delete a folder, because the rule of deleting a folder is you cannot delete a folder unless the folder itself is empty. So recursion is useful in that case because you can use recursion to delete folders, one level by level. You have to delete the deepest level of folders first, and then the next level up will be empty, and then you can delete that folder, and then you work your way back up again. I also talked about, I think at the end of the class on last Thursday, I also talked about how you can use recursion to explore a maze. Did you guys remember that? Okay, it's called a depth-first search, algorithm, in which case you basically go as deep as you can until one of 2 conditions happens. One is you're revisiting a cell that you have seen so far, and 2, you encounter a dead end. Then you go back to the earliest point where you have some unexplored directions, and then you go into that direction again. But it can also be expressed as a recursive subroutine. So recursion has a lot of applications other than the kind of trivial application that we talked about in this class. Any other questions about recursion up to this point? No questions? Let's go ahead and just have one more example using just subroutines and local variables, and then we'll go forward from there. And this one is factorial. So we will see factorial again and again. It's just that every time we see it again, we add one more feature to it. Define factorial. And this time we have a local variable. Well, I'll call the local variable n. The first thing we do is we make a copy of a variable x, and we call it n a copy of that. And then we say if n is greater than 0, then we will say x gets x minus 1, invoke factorial again inside the conditional statement. When it comes back, what we'll do is we'll say r gets r times Well, let me see. There are two ways to do it. I can just use, reuse x for this purpose. So I will say x gets x times n. And if, oops, not yet. I have an else here. The else is, what if n is not greater than 0? If n is less than or equal to 0, I'll just redefine the value of x so that x becomes 1. And if n define sub, and then we have to give it proper indentation. Let's see, where's my little indentation tool?
Down to the left.
Oh, right there. Thank you. And then we have to select these guys and indent just those. And then we need 2 more lines. The first line is to indicate, which numbers factorial do I want to compute, and that has to be stored into x. So let's just say that we want to figure out what is 2 factorial. 2, 3, 2 factorial would do fine. And then we just invoke the subroutine called factorial. Okay, are there any questions about the code itself? No questions? The subroutine? There are no questions? Is everybody convinced that at some point we have to stop the recursion and we will end up here? Because every time, when n is greater than 0, we go in and we decrease the value of x by 1. And so the next time when, in the next recursion, when we assign x to n will be 1 less than what it was in the previous invocation. So at some point it has to get down to 0. When it does get down to 0, we get to this case here. We reinitialize x to 1. In other words, I am reusing the variable x to store the result of the factorial. And then it goes back to this point, and I just multiply x, which is the result from the previous invocation, from the next invocation by n itself, and this way I can compute the factorial of n. Now we'll go ahead and try this out. We will need one column for comments because we do have conditional statements in this case, or one single conditional statement. In this case, we have line number, and we have one single global variable x. And remember, eventually we want to remove all global variables because we don't want to use any global variables in our programs. But at this point, we have to have some global variables because there's no way for the code outside of the subroutine to say which numbers factorial do I want to calculate, and there's no other way for the subroutine to tell me the answer of that factorial. So I have to use a global variable for that purpose at this point because we are not done with all the topics yet. When we talk about parameters, then we'll have a way so that we don't need to use any global variable at all. But at this point, that's the only way for a subroutine to communicate with the code that is outside of the subroutine. The precondition is I don't really care what is in x because I am going to initialize it anyway right away on line 12. So here's line 12, and x is initialized to a value of 2. Then on line 13, we invoke the subroutine. Now, since this is the first time we actually do this in recording, I'm going to spell out exactly what we have to do when we invoke a subroutine. The first thing we want to do is to allocate a new column so that we can remember where to go back to when the subroutine is done. In this case, we have to allocate column D, label it return line number, and then we have to say, okay, which line am I going back to when this invocation of factorial is done? What should be the answer here? Post, because there are no additional lines after line 13, so that's entirely correct. Very good. And then we'll proceed on the first line inside the subroutine, which is line 3 in this case. Line 2 is just a declaration. It doesn't really do anything useful. But since we have a local variable, we also have to allocate another column for the local variable n. So in this case, I allocate column E for my local variable n. And this is something that you have to remember, is all local variables start with unknown values. Okay? It is not true for all programming languages, but it is a safe assumption. If you always remember that local variables always start with unknown values, nothing bad can happen because it will just force you to reinitialize a local variable. And this is also the case in C programming, and most of you are moving on to cisp300, so this is definitely appropriate for this class. Are there any questions up to this point? Basically, we are kind of still revisiting concepts that we have seen already from last Thursday. Okay, on line 3, we are going to do one thing. We are going to copy the value of variable x, which is a global variable, to n, which is our local variable here. So n is going to get the value of 2 because x has a value of 2 at this point. Then we move on to line 4. Line 4 is asking, is it true or is it false that n is greater than 0? It is true. So we go into the subroutine, we go into the conditional statement starting on line 5. Line 5 says we want to decrement x by 1. X was 2, 2 becomes 1, and then we move on to line 6. Line 6 is an invocation of a subroutine. Now, remember last Thursday we talked about recursion and how this looks kind of confusing because I am invoking a subroutine that I'm in right now. But it really doesn't change the mechanism of invoking a subroutine at all. We go through exactly the same motion and they do exactly the same 2 steps when we invoke a subroutine, even though we are from inside that subroutine itself. The 2 things are we allocate a new column, label it return line number, and in that column we have to say when we are done with the invocation of the subroutine, where are we going back to? In this case, the invocation is on line 6. There is a line 7 that follows line 6, and that's why the return line number is line 7 in this case. And then we have to transfer control to continue execution inside the subroutine from the first line in the subroutine. In this case, we start with line 3 again. Are there any questions about this part of tracking a subroutine? No? Okay. But there's one more thing to do because we have a local variable in this case as well, and the local variable is n, and it is always starting with an unknown value. Column G is another case of local variable n. Are there any questions about this part?
Is it specific to that algorithm? Why?
No, this is not specific to a particular algorithm. It is specific to the properties of local variables. A local variable, which is n in this case, is not associated with a subroutine. It is actually associated with the invocation of a subroutine. So even though we only have one subroutine for Factorial, each invocation of Factorial gets its own copy of n.
But that's different from the homework assignment setup that we just tomorrow, in that we don't. Did we allocate n for n on the?
I cannot remember the homework assignment.
I don't think there are any local. There's no local variable.
There are no local variables, so there's nothing to allocate in your homework assignment. Okay. But are there any questions about n? Is taking up your both column E and column G because it is per invocation. It is not per subroutine. Okay, and that's the only way that makes it useful because this time when I go to line 3, I make a copy of x and copy that into n. X now has a value of 1, and this time I'm using column G as my n because I only focus on the rightmost columns that I have allocated. So even though I have 2 columns that are both labeled n, the subroutine that is currently active can only see the n that is the most recently allocated one. Are there any questions, why, we can resolve, which n we refer to? Because we only focus on the right-hand side of the columns. Any questions at this point? Yep.
I had kind of a general question.
Go ahead.
If the local variable just disappears after the subroutine, how do we use it for anything?
It's basically a scratch pad. So during the calculation of something, you would use the scratch pad, but it's like scratch paper. Okay, when you're done doing the calculation, the scratch paper itself is not useful. So you basically clean up after yourself and you toss it into the trash can when you're done with that particular problem. Okay, so it's kind of like that, and there will be more additional, there will be additional concepts that are kind of like local variables, but kind of like local variables, but not exactly. Okay. Any other questions about local variables? And basically the most important part is it is a per invocation thing, just like the return line number is a per invocation thing. So we go to line 4 at this point. Line 4 is asking the same question. N is greater than 0 is true, but this time it is greater than 0 because n is 1, not because n is 2. We still have to go to line 5. Line 5 is going to decrement x by 1. X will go from 1 to 0. Then we go to line 6 again. And line 6 is going to invoke the subroutine one more time. And what I can do is to shrink the columns just a little bit so that we can see the entire picture. And once again, when we invoke a subroutine, we have to allocate a column for the return line number. And once again, we are going back to line 7 when the subroutine is done, because the invocation is on line 6 itself. And we also have to allocate yet another column for local variable n, because this is another invocation, and variable n needs to be allocated per invocation. So now we have column I allocated for local variable n. And then just like last time, when you are done with setting up all the columns, you continue execution in the subroutine that is being invoked. But you always start from the very beginning of the subroutine. So when we start with line 3 again. Line 3 is making a copy of x into n. X now has a value of 0, so n is going to get a value of 0. Then we go to line 4. Line 4 is asking the same question, except the answer this time is false, because n, which is column I, now has a value of 0. Now, this does not mean that we have only one n at this point, because we do have 3 n's, of all the columns. It's just that only one is visible to the subroutine that is active at this point. In other words, the computer is keeping track of all the different versions of n all at the same time. It's just that we can only see the latest one that we allocate. Is that okay so far? Are there any questions regarding the concepts of which n are we talking about? And it seems kind of confusing that we have several n's here. Are there any confusions? Nope. Okay. So when the condition is false with the conditional statement, we do not get onto line 5. Instead, we go to the else case, and we continue with line 9. And this is the trick that I usually do, is I use this little thing here so that I can display certain portions of the spreadsheet, up to here, and I can scroll the bottom part, to somewhere else. Continuing execution on line 9, x now has a value of 1. And then I get out of the conditional statement. I end up on line 11. At the end of a subroutine, the first thing we want to do is to look up the most recently defined return line number column, which in this case is column H. Column H tells me that I have to continue execution on line 7. So here I write down 7 first, just so that I remember that I should continue execution on line 7. Then what I do is I will go ahead and remove the 2 columns, or deallocate the 2 columns that I allocated at the beginning of this invocation of the subroutine. Now this part is kind of symmetric. If you look at the allocation as an open parenthesis, the deallocation is like a closed parenthesis. If you allocate at the beginning of an invocation of a subroutine, you have to deallocate the same thing. Are there any questions about this part here? Why on line 11 we take column H and column I and remove those 2 columns, or deallocate those 2 columns? No questions? Okay. And after line 11, I continue execution on line 7. Line 7 says we want to compute x times n and then assign that result back into x. And for that to happen, I have to look a little bit ahead, or top, on the top, because now we are referring to this n. N is 1, x is 1 as well. 1 times 1 is 1, and we're going to store that back into x. X is now updated to be 1 again. And after line 7, I go to line 11 again. And line 11 is doing the same thing, except this time I'm not looking at column H. This time I'm looking at column F, because column H is already deallocated, I cannot use it at this time. Column F tells me I have to continue execution on line 7, so I remember that first. And then we go ahead and deallocate the two columns. Column F and column G are now deallocated. Are there any questions about this part? No questions? And where are we now? We are back to line 7. Now, even though we are back to line 7, the context is no longer column F or column G or column H or column I. We are now back to the context of column D and column E. On line 7, when we compute x times n, the n is now column E, which has a value of 2. X being a global variable is always column C, which has a value of 1 at this time. 1 times 2 is 2, and we are going to store 2 back into x. So x will now be updated to a value of 2, and then we get out of the conditional statement. We end up on line 11. Line 11 is the end of a subroutine. We do exactly the same thing as last time. We look up the most recently defined return line number, which is column D. It tells me we have to continue execution at post, and then we delete or deallocate those two columns, so they are now available if there was any code after this. And when we continue execution at post, that means we're at the end of the entire algorithm and we are done. Are there any questions about this trace? No questions?
Is it on the test?
It will be. This is just the beginning of subroutines too. Well, I would say it's a little bit past the beginning, but there are more stuff to talk about in terms of using subroutines. But are there any questions about? Yes, go ahead.
Okay, so you're telling us that in order to retain a value after the subroutines, we have to have a global.
At this point.
At this point. Oh, okay.
Mm-hmm.
Well, then maybe my question's invalid. Then I was gonna ask if we have two subroutines running. If we used a different local variable, so if we'd have two of them, would the other subroutines be able to refer to?
No.
No. Okay.
A subroutine in C can only see its own local variables.
Okay, so even though it's within another subroutine, it still wouldn't be able to see it, even if it was
You are
allocated
correct.
differently?
You are correct.
Okay.
In C, a subroutine can only see its own local variable and only the current invocation as well. So it's very specific. The visibility of your local variables is very specific. It is only the current invocation and also just the current function or the current subroutine that you are in at that time.
Okay.
In some other languages like Pascal, you can actually see somebody else's local variable if you have a nested definition of subroutines. But no other programming language these days have the concept of a nested definition of subroutines. So that topic is no longer relevant because no one uses Pascal anymore.
Okay.
Okay. Good questions. Any other questions related to the use of local variables? Yep.
In this case, could you have a global n and a local n?
If you have a local n, it will obscure the access to the global n.
Okay.
So if you had a global n, it would not be visible anymore when you're inside the subroutine.
Okay.
Good questions? Any other questions about this particular program? No questions? Okay. So at this point, we are still using global variables, okay, or one single global variable, because x is a global variable, and at this point, we don't have any mechanism to basically get away from the use of global variables altogether, because there's no other way to pass, which values, Factorial do I want to find. There's no way to pass that information into the subroutine to begin with, and x, served that purpose. And on the other side, when the subroutine is all done with its own calculations, there's no way to pass the result of the factorial back out to outside of the subroutine, and we had to use a global variable, in this case the same global variable for that purpose. So at this time, we still don't have all the tools that we need in order to get away from using global variables altogether. And that's why we will talk about the concept of a parameter next. Let me save this file first. So this is Factorial using just local variables. Let me go back to the website here, and I'll open up several tabs to show you where we are in terms of the modules. If you look at module 73, where we are at right now is we are just going to begin to talk about parameters or section 3. If you go to module 232, we are done with section 4 and we are going to begin with section 5. Those two modules are kind of closely related. As the name implied, I wrote module 73 first, a long time ago, about 5 years ago. And then since then, I have kind of refined the way I talk about local variables and use column numbers to refer to the local variables. And that's why we have another note here that was written just last year in December. So what you want to do is to read both because they are still kind of consistent by themselves. But the later one is probably more clear in terms of the terminology, and it is more consistent with the way I teach the class now, using the column numbers to refer to the columns. Okay. But this is where we are at this point. We are going to talk about by-value parameters at this time. Okay. The purpose of a by-value parameter, is almost like a local variable, except for one thing. Its initial value is specified by the invoke statement of the subroutine itself. So that means by-value parameters can serve one important role in your algorithms. It can serve as an in-tray for a subroutine. Okay, if you want a subroutine to compute, the value of blah 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 blah, like the factorial of a number, now you can pass the number in to the subroutine without the use of a global variable. That's the role, or that's the purpose of a by-value parameter. It can pass information into the subroutine without the use of global variable. So let's go ahead and rewrite our factorial program to use a local variable, to use a by-value parameter. And I will start to write this one from scratch, just so that I can talk about it as we write it. So once again, we have factorial, but this time instead of a local variable n, I will call this a by-value parameter or by-value parameter. If you type by value, it is not a problem. If you type by val, it's not a problem. If you type by val without a space in between, it's not a problem. As long as I can see what you mean, that's okay. And then we have to give the variable a name, or the parameter needs to have a name. I will call this n because it really is doing the same thing as what n did in the previous version of this algorithm. So this time the algorithm is actually quite a bit simpler because I can say if n is greater than 0, then we want to invoke factorial again. Invoke factorial. When factorial comes back, we'll go ahead and finish up the calculation. So the result of the calculation is going to be the result of the factorial times n itself. And then we have an else here. The else corresponds to what if n is less than or equal to 0. In that case, r gets 1. And if n defines sub, and then we'll go ahead and fix all the indentations. So, and this time from the outside, we have to invoke factorial. Okay, but there's one thing is missing. One thing is missing is, but I haven't really talked about which numbers factorial do I want to calculate, because if you look at this whole thing here, that information is missing entirely. And that's why the invoke statement now needs to be extended a little bit, because within the invoke statement, now we have to say, oh, by the way, I want this parameter n to start with a value of 2. Okay? Now this notation is only used in this class. In your other classes, when you pass a value to a parameter, you just spell out the number. You don't have to say which parameter is getting this value. But in this class, we spell it out so that it is absolutely clear, which parameter is getting which value. And we also have to do something about this invocation of factorial, because we don't want to just invoke factorial, because otherwise, what is the value of the parameter n? We have to specify what it is, and this time it's more confusing because it is n minus 1 going to n. Okay? So when we trace this, we'll find out exactly what is going to happen on line 10, which is the easy one, and also what is happening on line 4, which is the more confusing one. Okay? But this example is going to illustrate why we have parameters. So here we have the code, and now we trace it. And we have the same problem as last time. I also found out what that problem was. It's a driver issue. For some reason, it's not using the proper driver. I can shut it down and make it go again. That will fix the problem. Except it will take up time as well. Yep.
It didn't do anything earlier when you resized from the other side.
I have to resize this one, I think, and then save it so that it knows, about the new size. Let me try it again. Yeah, it worked okay this time. All right, let's go ahead and trace this algorithm and find out what the parameter is going to do. We still have the comments column, we still have the line number column, and this time we still have one global variable r. Now, the purpose of global variable r is only one purpose now. It is only used so that we can pass the result of the calculation out of a subroutine. It is no longer used to pass the information into a subroutine, because that particular row is now done by n, which is now a parameter, no longer a local variable.
So you said r is a global variable?
R is a global variable, but n is a parameter now. It is not a local variable. A parameter that is passed by value, if you want to remember what it is, you can remember it is just like a local variable, except its initial value is specified by the invoke statement. That's the only difference between a by value parameter and a local variable. Yep.
Okay, so you're saying that when we say invoke 2, the 2 is actually
2
going
to n.
to r?
Sorry? But r is still a global variable, because on line 5 and on line 7, we have to refer to r. And r, since it is not by val, it is not a local, it has to be a global variable.
Okay, but then for this to work, doesn't it still need an assigned value?
R?
Yeah.
It will get a value eventually. It will get a value on line 7 eventually. So as the precondition, I can leave it undetermined. Is that okay?
I'm still confused, but maybe when you go through it all.
No, go ahead. I want to know you.
Well, I mean, we know it's not defined, but looking at the factorial, we're going to be multiplying r times n, but
Right.
r hasn't been given a value yet.
That's okay, because we will encounter line 7 before we encounter line 5.
Right.
So
Okay,
that's why
correct.
we can kind of leave it undetermined at this time. That's a good question. It's good to think in that line to basically say, okay, when we do the calculation, can we use it because it has no value at this time. So now we are on line 10. Line 10 is the only line outside of the definition of the subroutine, and we start with that one. And line 10 does not initialize R. All it does is to invoke the subroutine. We'll do the familiar thing first, and then we'll do the not so familiar thing. The familiar thing is to set up return line number. And we have to indicate where do we go back to when the subroutine is done. In this case, because line 10 is the last line of the entire pseudocode, the return line number is going to be post. So that is the part that we are familiar with. And also, when you invoke a subroutine, you have to go to the first line inside the subroutine, which in this case is also line 3, just like the previous program. The not so familiar part is what do we do with a by-val parameter? Remember what I said? By-val parameter is just like a local variable, except its initial value is specified by the invoke statement. So what do we do with local variables?
We know they're preconditioned.
Well, we have to allocate a column first, right? Okay, so just like with a local variable, we have to allocate a column for parameter n. In this case, it is column E. I think it's just like last time. Except this time, we don't put a question mark here. Because a question mark is appropriate for a local variable. All local variables start with some unknown value. But since this is a parameter, its initial value is specified by the invoke statement. If you look at statement 10 or line 10, it says specifically, I want parameter n to start with a value of 2. Okay, so that's the difference, because this time n starts with a value of 2 because it is a parameter. The invoke statement is responsible to specify the startup value or the initial value of a parameter that is passed by value. Are we doing okay so far with this? Okay. So now we can move on to line 3. Line 3 is checking whether n is greater than 0. N greater than 0 is true because n has a value of 2 at this time. So we go into the subroutine, we go to line 4. Line 4 is the invocation of factorial again. So this time again, we'll do the familiar thing first, and then we'll go back and say, okay, but some part of it doesn't look right. I mean, it looks kind of confusing. The first part is setting up the return line number. That's the easy part. We allocate a column, we label a return line number, and then we use the line that is logically following the invoke statement. In this case, because the invoke statement is on line 4, the next line is line 5. Line 5 is logically following line 4. So we say, okay, we continue execution. Oops, I got it wrong. We have to remember to go back to line 5, and then we go to the beginning of the subroutine that we're invoking. Since we're invoking factorial and it starts on line 3, we have to continue execution on line 3. Okay? That's the familiar part. The not so familiar part is, oh, we also have a parameter n to set up. How are we going to set up parameter n? The first thing is we know we have to allocate a column. That's the easy part. We allocate column G for our parameter n. The next question, which is the confusion part, is what are we going to write, or what is the initial value of this column n in a parameter n, which is column G?
1.
It is 1. But why is it 1? I mean, it looks kind of confusing here. We are using n to set up n. Now, when you look at this n minus 1, which n do you think it is referring to? Is it referring to the n that we are setting up? Do you think it is referring to the n that we already know?
Previous one.
The one that we already know, which is column E. Okay, so column E is the one that we are referring to, when we specify n minus 1, and the n on the right-hand side, which is the n that we are setting up, that's referring to column G, which is the one that is being created at this time. Does it make sense that we'll use column E for the left-hand side of the right arrow, and then use column G for the n that is on the right-hand side? Why do you think I picked that symbol, the right arrow, in this case? It indicates one thing. What does it indicate?
The new value is going to be put in the right logic.
Exactly. The calculation, which way does it go? Okay. So that's why column G is going to start with a value of 1, because it is 2 minus 1. Are there any questions about this step here? Because this is the most confusing step of these entire trace.
So the main difference between a parameter and a local variable is the fact that the parameter can still look into the previous value before it assigns.
Because the invoke statement of the invoke statement is responsible to set up a parameter,
Right.
which gives it just for an instant it has access to the parameter that belongs to the invocation that will happen next. Okay, is that kind of doing okay? Whereas a local variable does not have any exposure to the invoke statement itself. And that's the main difference, and that's why it works, because this is how you can pass information into a subroutine without the use of a global variable. So now that we continue execution on line 3, we ask the same question. N is greater than 0 is still true because n, which is column G, now has a value of 1. Then we go to line 4 again, and we do exactly the same thing. We set up the return line number, and when this invocation is done, we want it to return to line 5 again. And then we continue execution on line 3, which is at the beginning of the subroutine that we are invoking. We are also going to set up a new column for parameter n. And this time, this parameter n is going to be 1, which is column G minus 1. 1 minus 1 is 0. And that's why column I has a value of 0. So let me just kind of stop here and make sure everybody is okay, and understand what we are talking about here. Are there any questions regarding the trace at this point? Is that okay? Okay. So as I said, the most important part they have to remember regarding by-val parameter is they are just like local variables, except for one thing. The initial value of a by-val parameter is set up by the invoke statement, not by the subroutine itself. Is that okay? More or less?
So
Okay.
anything that you could legally use, anything that you could assign to the value of a variable could be used as a parameter?
Correct. Yep. But the left-hand side of the right arrow, all that stuff refers to what you know at this time. The right-hand side refers to the one column that you're setting up. That's the part that can be confusing. So we are going back to line 3 again, and this time it is still asking the same question, except the answer is different this time, because n, which is column I this time, has a value of 0. 0 is greater than 0 is false. So we bypass the then portion of the conditional statement. We go to line 7. Line 7 says R gets a value of 1. So that answered your initial question. It was a good question. It's just that in this case I knew that line 7 would execute before line 5, and that's why I was not initializing R. After line 7, we go to line 9. Line 9 is the end of a subroutine. The cleanup part is exactly the same as a local variable, and that's why I said a by-val parameter is almost like a local variable with only the exception of its initial value. So when we are on line 9, which is the end of a subroutine, we do exactly the same thing as we always do. We look up the rightmost return line number. It tells us we have to go to line 5 to continue execution. We make use of that fact first, and then we deallocate both columns that we allocated earlier. It doesn't matter whether it is a local variable or a by-val parameter. If you allocate it for this invocation, at the end of the invocation, you also have to clean it up. Now we continue execution on line 5. Line 5 wants to compute R times n, and then update R with that value. N this time is column G. It has a value of 1. R has a value of 1 as well. 1 times 1 is 1, and I'm going to use that to update R, which is column C. So R is updated to 1 again. Now, even though it's updated from 1 to 1, I still have to write it because I have to indicate that this is a potential place where the value of a variable can change. After line 5, I get out of the conditional statement. I end up on line 9. Line 9 is doing the same thing as before, except this time I'm using column F to tell me where to continue execution. It tells me the next line to execute is on line 5. And after that, I have no use of column F or column G anymore. I deallocate both of these columns, and then I continue execution on line 5. Line 5 is doing the same thing, except this time n refers to column E. Column E has a value of 2. R has a value of 1. 1 times 2 is 2. I use that to update the value of R. R is now updated to 2. I get out of the conditional statement. I end up on line 9. And then we look up the return line number. It tells us we have to continue at post. And then I have no use of column D or column E. They get deallocated. I continue execution at post, and that tells me I'm all done. Are there any questions about this particular trace of basically the same algorithm. This is really the same algorithm, except we use the concept of a by-val parameter instead of using a global variable to pass information into a subroutine. Are there any questions about this one? Yep, go ahead.
What do you do with your result from a subroutine?
Aha, that's a good question. So you're basically asking, how do we get rid of the global variable responsible to pass information out of a subroutine? That's the next topic. Okay, very good leading. That's a good question to ask. There are two ways, to answer the question. One is what we call a by-ref parameter, and the other one is called the return value. We'll use the parameter method first, and then we'll talk about the return value method. Are we okay with this trace? No more questions about this one? Which one do you think is a little bit cleaner? This one is cleaner. Okay, this one does not use up as many columns, and also the code is cleaner because we don't need to do the assignment from the global variable into the local variable to take a snapshot of it. So we'll go ahead and save this one. Oh, got to the wrong folder. Let's see. Back up. And I will call this one Factorial by val, okay, because we're using a by val parameter. Get rid of this. So the next topic, we are done with by val parameter at this point, at least in terms of concepts. So the next slide talks about by reference parameters. Passing by value is only useful to let an invoke statement pass information into a subroutine. However, a parameter that is passed by value cannot pass information from the subroutine to outside of the subroutine. Okay. So let me show you an example first. This is not factorial. It has to do with swapping the values of two variables. So let's go ahead and write that code. Define subroutine, and this time we want to swap the values of two variables. In other words, if a variable x had a value of 5 and variable y had a value of 7, I want them to be exchanged. Okay, so swap is basically the same as exchanging the values of two variables. So this time, I'm smart, okay? I know the concept of a by-val thing, a by-val parameter. So I would say x is a by-val parameter, and I would say y is a by-val parameter, and I would need a local variable t to help me finish up this task. The task is fairly easy. T as a temporary variable will take a snapshot of the value of x before I change the value of x. X will get the value of y, and then y will get the value of x before it got changed. Well, lucky thing that I saved it a little bit earlier. It is not. It is in variable t at the time, and this is it. This is the logic to exchange the values of two parameters. Of two variables. And then outside of the okay, let's just take a look at the swap subroutine at this point here. Do you think we have any references to global variables at this time? Are all the names accounted for either as a local or a by-val?
Yes.
Okay, so we are not using any global variables, which is good. Okay. So outside of the subroutine, I have some global variables. Let's say I have I, which gets a value of 5 first. I have j, which gets a value of 7. And then I invoke the subroutine called swap, and I say, oh, I would use I to specify parameter x. I would use j to specify parameter y. Go ahead and exchange the values of those two things and give me the result of that. Okay. Now we know it's not going to work because they are by-val parameters, but we still want to see what it looks like in a trace, and then we can fix the program in a very minor but important way so that it works properly. So let's go ahead and see what this program is going to do. This one does not have recursion. All right. We don't even need a column for comments because there are no conditional statements, there are no loops in this case. So we can start with line number, we can start with global variable I and global variable j. All global variables are, they exist from the beginning of the execution of the pseudocode all the way to the end. And that's why I and j are allocated columns from the very beginning. The precondition is I don't really need to know anything because they will both be initialized after this. Okay, then we start on line 9. Line 9 is going to initialize I with 5. Line 10 is going to initialize j with 7. Easy stuff. Then we go to line 11. When we get to line 11, we're going to invoke the swap subroutine. But we already know how to deal with it. We already know how to invoke a subroutine. We also know how to deal with by-val parameters. So we'll just go ahead and do this kind of stuff that we already know. We set up a return line number, which is telling the subroutine where to go back to when it's all done. Since there are no lines following line 11, the return line number is going to be post. And then we also continue execution on the first line of the subroutine. In this case, the first line of the subroutine is line 5 because the other 3 lines are just declarations telling us what x, y, and t are. But remember, with all the by-val parameters, we also have to set up columns for all of those by-val parameters. We have one by-val parameter called x, one is called y. Okay. What do you think is the initial value of x?
5.
Exactly. Okay. Now even though it is obvious that it is 5, it is important to say 5 instead of I. Okay? Because the expression on the left-hand side of the right arrow can be anything. Okay? It can be I times 1. Okay? If it is I times 1, then you're just copying the value. But in this case, we are always copying the value. It is important not to write down I when you initialize x as a by-val parameter. And then the same thing applies to y. It is 7. It is not j. In other words, the by-val parameters basically become copies of I and j in this case. Okay? Now that, it doesn't seem like a very important thing, but it is one of the most important parts of a by-val parameter is it completely decouples its value from where it got the value from. Yep.
So if we don't have values for I and j, would that all of a sudden make x and y the same as I and j?
No.
Okay.
No, if you don't have any values for I and j, you simply don't know what the program is going to do. So that would be bad, but it's not what you described.
So like you're saying, it completely decouples from I and j.
It just makes a
copies
copy.
the values.
Yep, exactly. Yeah, go ahead.
So is that true not just of the by-val parameters, but of variables in general? If you assign the value of 1?
That is correct.
Okay.
Yep. Because if you just have a regular assignment statement, x gets the value of I, it's only going to copy the value of I into x. But x after that is completely independent of I. You can change I all you want, and x keeps its own value, and vice versa. Okay? So in this case, it's the same thing. I can change the value of I as a by-val parameter all I want, but it does not impact I anymore, and that's the problem of this algorithm. Okay? Well, let's go to line 5 and see what we are going to do here.
Forgot T.
Oh, I forgot T. Thank you. Now T is a little bit different. Why is T different from X and Y?
So local
It's a
variable.
local variable, so what do I put here?
Question mark.
Question mark. Very good. Okay, so we have to set up 4 columns for this, subroutine. Yep.
Does it matter are you doing it because the way you called it, the way you're setting up the columns, or is it parameters first, or does it not matter as long as you make
In this class, it does not matter. Okay, in this class, it does not matter. But when you move on to cisp300, which is assembly language programming, then I will reorder these things, because there's a specific order, in that class. But in this class, in general, I just don't care what order do you want to put those things in.
All right.
All right. So now we have x, y, and t, all done. We know where to go back to when the subroutine is done. We can now continue execution on line 5. Line 5 is pretty easy. We take the value of x and then we use that to update the value of t. X has a value of 5, so t ends up with a value of 5 as well. We go to line 6, we copy the value of y to x. Y has a value of 7, so x is now updated to a value of 7. Not a problem. We go to line 7, we copy the value of t to y. T has a value of 5, so now y ends up with the value of 5 as well. So by the end of the subroutine on line 7, you can see that the values of x and y are in fact exchanged. X was 5, y was 7. Now x has a value of 7, y has a value of 5. So we successfully exchanged the values of the parameters. Did we do anything to I and j?
No.
Not a single thing. But since we're at the end of the subroutine, we have to go to line 8. Line 8 is still doing the same thing as usual at the end of a subroutine. We look up the return line number. It tells us we have to continue execution at post. So that's what we do. Next. And then we have to deallocate all the columns that we allocated earlier. This time we have 4 columns to deallocate because for this invocation we allocated all 4 columns. So by the time we get to post, which is the end of the algorithm, nothing happened to I or j. And that has to do with the nature of a by-val parameter being decoupled from the original things. They are basically copies of the original. You can do whatever you want with the copies and nothing happens to the original. Okay. So are we doing okay with this algorithm, why it is not working the way it is supposed to? Okay. All right. So let's go ahead and save this one first, and then we'll fix the problem by using by reference parameters. So I'll say this is bad swap by value. And then what I'll do is I'm going to save the file again. This time, I'll rename the file as good swap by reference. Okay, because the code is almost exactly the same, but the meaning of the parameters are now changed completely. The way I do that is I change what x is. I change x from by val to by reference. And the same thing happens to y. Instead of by val, it is now by reference. I also have to change the destination or how I draw the arrows, because now they are a double-sided arrow. And so is the other one. Now remember, in other classes, you won't see the arrows at all, because it's just implied in other programming languages. But in this class, I use the arrows to really emphasize the concept of, oh, guess what? What happens to x goes back to I. Whatever I was, x becomes that. So they are basically the same thing. The trace is going to be changed as well. So what I'll do is I'm going to delete everything here. And I can keep this one because I still need to deallocate 4 columns, except the columns won't be the same anymore. So let's go ahead and get started with this one. The first 2 lines or first 3 lines are almost the same. Line 9 is still doing the same thing. I gets a value of 5. Line 10 is still doing the same thing. J gets a value of 7. But line 11 is a little bit different now. We still have a return line number column. It is still going back to post. That part is still the same. After I set up these columns, I still have to go to the first line inside the subroutine, which is line 5. I still have the local variable t. T is still here. It is still starting with an unknown value. That's fine, not a problem. What is changed is what is x and what is y in this case. This time we need a little bit more space than before because we have changed the nature of the 2 parameters. So before we talk about this part here, let me just give you an analogy of what is passing by value versus passing by reference. Let's say use the library and books, checking out books as an example. Up to this point, a local variable is nothing more than a scratch pad that can materialize anytime you need to use a scratch pad inside the subroutine. Okay, so when you get into a subroutine, the scratch pad will materialize out of thin air. Okay, but it's blank. There's no content on it. Okay, or uninitialized, if you will. Then you can use it any way you want, and then when you're done, before you get out of the subroutine, you have to toss it into the recycle bin because it is no longer useful. You cannot take it away with you. When we talk about by-val parameters, it is the same thing as, oh, this is the document that I want you to process, but I'm not giving you the original. I'm going to a copier, I make a photocopy of that thing, and then I put the photocopy on your in tray. So as a subroutine, you take it from the in tray, and then you do a lot of processing, potentially changing the documents in the process. But when you're all done, guess what? You still throw that into the recycle bin. Passing by reference is different. It's still an in, it's still a bin that you give, it's still an in bin from the perspective of the subroutine. But what you're giving the subroutine is no longer a copy of the original. And you're not giving the subroutine the original either. What you're giving the subroutine is how to find the subroutine. How to find the original. Okay? So using the example of the library, before, we have a blank notebook to begin with, which is a local variable. Passing by value is saying, oh, I'm going to check out a book, but I won't give you the original book. I will make a photocopy of the book, and then I give you the photocopy, so the subroutine will be working with a photocopy of the book. Passing by reference is giving the subroutine the call number of the book to process. Does everybody understand what is a call number in the context of using the library? No? Okay. The call number of a book is basically a unique, ID, if you will, of a book. You go to the library, I think computer science stuff, they're all QA something, QA 76, whatever. So you go to the shelf, QA 76, and then each book has its own call number. It's basically an ID, okay? It's an ID of a book in the library. What can you do with a reference? What can you do with a call number of a book?
Find the book.
You can find the original book and you can check it out. Okay? And that's what a subroutine can do now, because you are giving the subroutine not the original, but you're giving the subroutine the call number of the original. So every time the subroutine wants to do some changes to X, it can now find out where the original item is and change the original item instead of itself. Is that okay? I mean, the concept of, the call number thing? It's an address, if you will. Yep.
So I'm a little bit confused just by your analogy. So are you saying that the by reference parameter is like giving X the value of I instead of the contents of I?
It is not a copy of I, it is the instruction to find where I is.
But it's looking for the variable I and not the contents of I. Is that what you mean, or?
It's essentially X becomes an alias of I. Whatever you do to X happens to I. Whatever I is, X is as well. So they're basically the same thing.
But like on the by value, it was the value of I, which was 5.
It is a copy of I. It's a copy of I at the time of the invoke statement.
Oh, okay.
In this case, it is not. They basically are linked, completely. Yep.
It's not similar to the array where it would like find the value.
No, this has nothing to do with arrays. Yeah, it has nothing to do with arrays. Okay, so the way I represent that, in this class is I will say that X becomes an alias, aka also known as, and instead of using the variable name I would use the column of I. In this case, I is in column B, so X becomes an alias of column B. And you can probably imagine what happens to Y. Y is an alias of column C, because that's where J is. Okay? Is that working out so far? Does everybody understand the concept of an alias? Okay. All right. So, but this part alone, is not enough to illustrate the main differences between a by-val parameter versus a by-ref parameter, because it depends on what are we going to do, say on line 5. Okay, but line 5 is easy. Line 5 has x on the right-hand side of an assignment statement. So we want to look up the value of x. So we go to column E, because column E is where x is, but all column E is telling me is that x is an alias of column B. In other words, there's no value at this point, but it does tell me who might have the value that I'm looking for. So we go to column B, and column B says, oh, okay, I have a value of 5. So that's why we can still know that x has a value of 5 because x is an alias of column B, and column B has a value of 5, and that's why T is updated to a value of 5. Is that okay so far? Okay. I know it sounds like, oh, there are so many indirections, so many steps to perform just to get the value of 5, whereas before it is so easy to get to the value of 5. The next one is going to be more confusing on line 6. Line 6 has y on the right-hand side. So we do the same thing. We go to column F because column F has a label of y, and then we say, y, what is your value? Y says, I don't have a value, I'm just an alias. I'm an alias of column C. Go ask column C. Column C says, I have a value of 7. So that means y as a by reference parameter has a value of 7. Is that okay so far? That's not the difficult part. The difficult part is what do we do when x is on the left-hand side of the assignment statement, because we're going to change it. Okay? So we look up x and say, hey, x, you have to update your value to 7 now. Okay? So we go to column E because column E is where x lives. So we tell x, you have to change yourself now. You have to change your value to 7. And then x says, I don't have a value. I'm an alias. Okay? But I can ask column B to make a change. And column B says, okay, I'll change my value to 7. So if this is the line, this is the row that is important, that is the most important when we want to illustrate the concept of passing by reference, because you don't change the parameter itself. Even though x is the item on the left-hand side of line 6, you don't change column E. You change what column E is referring to. Okay? It's just like when you have a call number, and I say, go check out the book. Let me think of what I want to do to a book in the library, which you're not supposed to change, right? Let's just say that we are doing something that is not destructive. Okay, my instruction to you is, go clean up that book. Erase, all the marks left by, other students. Okay, that's what you're supposed to do. If I give you a copy of the original book, it doesn't do any good. Okay, you can erase all the marks, you can white out all the things that you're supposed to white out, and in the end, you have to throw the copy of the book into the shredder, and what you have just done is completely pointless. So instead of giving you a copy of the book that is, messed up, I give you a call number of the book. So what you do is you use the call number, which is a path by reference parameter, and you find the original item. So every time I refer to the book, I'm actually referring to the call number. And with the call number, you know how to find the original book. Are we doing okay so far, or am I adding more confusion to the whole thing? No? It's okay? Okay, so the key is there are only really two alternatives, because when I execute line 6, I have two choices. Either I change column E, because column E is variable x, or I change what it is referring to, okay? But the first choice is the incorrect choice, because you have to update whatever x is an alias of. In this case, since x is an alias of column B, I update column B. Are we okay with this concept? Okay. So as a general rule, if a particular column is AKA something, you don't change that column. You change whatever it is referring to. So on line 7, it becomes easy because the right-hand side is t. T is a local variable. It has a value of 5. Not a problem. What are we changing? What are we changing to a value of 5? We're changing y. Y is AKA something. We know not to change column F. So instead of changing column F, we are changing whatever column F is referring to. It is referring to column C. Column C is now updated to a value of 5. And then we get to the end of the subroutine, which is on line 8. And line 8 says, we have to look up the return line number first. We have to continue execution at post, and then we deallocate all 4 columns that we have allocated earlier, and we are done. Now, but hold on a second here, Tech. What exactly are we shredding? Because we are shredding 4 things, okay, after the end of the subroutine. See, if we are not shredding the things that have the values of 5 and 7, what exactly are we shredding? We're shredding the little slip of paper that has the call number written on it. So we're not shredding a book in this case. We're simply shredding the instruction to find the book. So that's why the books are fine. The books are still here. We're just shredding the instruction to find the books. Are we doing okay so far with the concept of passing by reference? It's okay? Yep.
Is there an easier way to swap the variables?
Nope, there are no easier ways to do it. You need 1 temp variable and 3 assignment statements to do it. Yep.
How can we say AKA column B instead of AKA I?
The difference is, what if you have local variables and you have a reference to a local variable? It becomes confusing when you say AKA I or AKA J, but when you refer to a column number, it is absolute. We know exactly which column we are referring to. And that's one difference between the old notes that I have, which refers to the name of the variable, and the new notes, which refers to the column reference of the variable that we refer to. Yep.
So in what you just talked about, it implies that it's possible to have it represent either a local or a global variable. So how do you specify which it would actually be?
Very good. Good question. We have about 5 minutes left. I think we can finish the next example to illustrate exactly that. So we'll close this, save it first, and do it. The last example. So what you're talking about is something like this. So in this case, I will just have a very simple example here. X is passed by reference. X gets initialized to 0. Okay. And define sub. I have another subroutine that I call pointless. Okay. Pointless has a local variable I, and then I say invoke reset. I use I to specify parameter X. Define sub, and then from outside of the subroutines, I just have to invoke pointless, which does not require any parameters whatsoever. So this is a fairly pointless program, other than illustrating what we just talked about. It is a useless program. So let's go ahead and see if I can trace this in a few minutes. Okay, let's go ahead and get started. We have line number, and there are no global variables in this case whatsoever. So we will start with the precondition. There's nothing to say. We start with line 9. Line 9 will allocate 1 column for the return line number and another column for the local variable I. The return line number has to return to post because there are no lines after line 9, and I as a local variable is initialized to, there's no initial value. Then we continue execution inside the subroutine that we are invoking. In this case, it's pointless. Pointless only has 1 line to execute, which is line 7. Line 7 is invoking reset, so we have to set up the other columns. So let me change this a little bit here. Line 7 is invoking reset, and we have to remember where to go back to. So the return line number is whatever line that is logically following line 7, which in this case is line 8. Reset also has 1 parameter, which is X, but X is passed by reference. So the question now is, what are we going to do in order to specify X?
Column C.
Okay, now we know X is passed by reference, so that means it is always an alias of something. It's also known as what? Which column are we going to refer to?
C.
It is column C. Because I am using local variable I of point list, which in this case is column C, to specify parameter x of reset. So that's why parameter x of reset becomes an alias of column C. So we'll go ahead and just finish this up. We continue execution on line 3. We have 30 seconds to go, so we got plenty of time. So on line 3, we initialize x to 0, but x does not store a value itself. It is an alias of somebody else. So we have to store the 0 to whatever it refers to, which is column C. So column C is the one that gets a value of 0. We go to line 4. It is the end of the subroutine. So we deallocate these columns. And then we continue execution on line 8. Line 8 is also the end of a subroutine, so we have to remember where to continue execution, which is post, and then we deallocate those 2 columns that we allocated earlier as well. And that's the end of it.
So
We're just on time.
So if the by reference parameter is invoked in a subroutine, then it will be for the local variables of that subroutine.
Yeah,
or
either
other
local variables or it's by-val parameters, because by-val parameters also have their own values. So any column that can store its own value, you can have a reference to that. So the trickiest part is, what if you use a by-ref parameter to pass to another by-ref parameter? So we'll talk about that next time.
A biref is allowed to leave the subroutine. A reference, it can leave the subroutine.
Yes.
That's the only one that's allowed.
Yes, because we told it what it is a reference to. Okay. In other words, it's kind of like passing by value. The invoke statement is the one that gives meaning to a by reference parameter. Except in this case, we are not giving it a copy of someone else. We are saying, oh, by the way, when you want to make changes to X, make changes to this guy. And I'm telling you how to find that guy.
So outside the subroutine, make a change
Yes.
outside.
Yeah, this gives your subroutine the ability to access columns that are not allocated for its own invocation.
Okay.
And that changes everything, because up to this point, if we want to avoid the use of global variables, a subroutine cannot access anything other than the stuff that it allocates for itself. This is the mechanism that you can use so that a subroutine can change columns that actually belong to somebody else.
I see.
It's still cumbersome. There are better ways to do something like this, so we'll talk about that next time.
And by value, can that leave the subroutine or no?
Sorry?
A by value?
A by-val cannot leave the subroutine. You shred it at the end of the subroutine.
Yeah, by value is just taking the value, references
Another one.